Welcome to the Tes Podagogy podcast. How does early mathematical ability develop? What role do early years practitioners have in that process of development? This week, we're asking those questions and more to Professor Camilla Gilmore. She's Professor of Mathematical Cognition at Loughborough University and the co-director of the Loughborough's Centre for Mathematical Cognition. Camilla, thank you for joining me.
Thanks, it's nice to be here.
So number is sort of the poor cousin of literacy in early years a lot of the time. We're obsessed with getting kids reading and all our attention's into reading, and numeracy tends to be this it's important, but there's a perception that it may be slightly less important than reading. And so with this podcast, we really want to have a look at early development of numeracy and what happens in those formative years. And I thought a nice place to start would be, is there a natural sense of number? Is this something that kids will do organically? They'll start to count, they'll start to notice, variations in number and amount.
Yes, well, so we know that children have lots of sort of informal, intuitive understanding of number that they bring before they get to any sort of early years setting. And so they do start with certain kind of cognitive tools, we could think of them as being, that allow them to see numerical aspects of the world. So one tool they have allows them to look at magnitudes and understand about representing and comparing approximate magnitudes. So they'd be able to know whether a set of 20 items was more or less than a set of 10 items, for example. Mm-hmm. So this gives them an approximate sense of the magnitude of different sets. And then they have another tool, they have another cognitive tool, which allows them to look at small sets of exact items. So to be able to identify 1, 2, 3 items and distinguish them from each other. Mm. So they bring these tools with them. But of course, this doesn't give them the symbolic representations, the number words and the symbols that we use for counting and for representing number. And so being able to exactly represent large numbers is something that can't happen without some input. So children need to be introduced to the count sequence, to the symbols for representing numbers, and they need some guidance in order to be able to do that. So there are intuitive, informal skills that they bring with them, but that's not enough on its own. They need to be introduced to the way that we have decided to label and represent exact numbers. I think another thing that's Sorry.
Do they understand, is it just many and few? Do they understand that 12 is more than 10 or 15 is more than 10? Or is that sort of this, identification sort of a bit beyond where they're at?
Yeah, so it's approximate. So how closely a comparison you can make or children can make depends on the ratio between them. Okay. And younger children will only be able to compare. So the very youngest children will only be able to compare things that have a ratio of 1 to 2. So they'd be able to distinguish 8 from 16 or 10 from 20. And then as children grow up and develop, the ratio that you can compare things reasonably accurately reduces, so children will be able to compare things in a ratio of 3 to 4 or 2 to 3, for example. And then by the time we get to adulthood, those ratios have gone to about 8 to 9. So we can make those kind of non-symbolic, approximate comparisons more accurately. So it's not just a case of more or less. It's determined by the ratio between the sets that we're comparing.
And so do those natural cognitive abilities in terms of magnitude, when let's say a child joins a preschool environment at the age of, let's say, the average of 3, when people's funding comes in, are we expecting a lot of variation in the children that come in, be it because of the background of the child, but also because of how children develop at different rates?
So we know that there are individual differences. When we look at older children and adults, there are individual differences in how closely we can make these kind of comparisons, so how precise this approximate representation is. I think we don't really have enough evidence from children at the age of 3 about that. And I think it's worth pointing out that when children are starting early years, really when they're looking to develop their number skills, it's more likely to be the other system that I mentioned. So this idea of being able to represent small numbers exactly, that's the tool that gets them into understanding symbols for numbers. So the magnitude representations that we have are likely to be helpful, and they can be part of the tools that children bring with them. But it's really thinking about small quantities and how children learn to connect symbols and number words to small quantities, which is the way in for most children when they start learning about number.
Is it possible to distinguish, let's say a child starts at school at the age of 4, and one set of parents have been teaching them all the number symbols and really putting a lot of effort into the numeracy stuff, and then other parents for whatever reason have not. Is it still possible to see the sort of, I don't want to say natural, I guess, but that's the best word for it, the natural ability of the child who perhaps hasn't had the input?
So there's a couple of interesting things here. So one idea that we have been able to identify is that some children seem to attend to number naturally more than other children. Okay. So in research literature, this is sometimes referred to as SPON, spontaneous focusing on numerosity.
Okay.
And so if you ask children, there's a number of little tasks that we can use to look at this. So for example, if you ask children to describe a picture, and there might be some animals in the picture and some clouds and trees, some children might spontaneously, without you knowing that you're looking for number, say, oh, there are 2 clouds and there are 3 trees. Whereas other children might just describe the colour of them or something else, or the arrangement. And other tasks where we ask children to imitate something that an experimenter is doing, a researcher is doing. And some children will pay attention to the number of times that the researcher feeds a toy or something like that, whereas other children won't spontaneously pay attention to number. And what we found is that how much children spontaneously pay attention to number in a situation where no one's told them to seems to relate to their maths development and their maths achievement, both a short time later, but also quite a few years later as well. So it does seem that despite whatever influences children are getting from outside, some children have this natural tendency to notice number and to pay attention to it. So that certainly there is evidence there that there's something that children bring that maybe help themselves to learn number. But then the other thing, when we look at the sort of home numeracy element, there's actually really mixed evidence there. So yes, there is quite a difference amongst parents in how much they're supporting their children's number. And some studies show that there are relationships between this and the children's number skills. But actually other studies show that there isn't, and it's actually the influence of the early years setting, or perhaps the early years setting working with parents, that's the strongest influence, rather than necessarily what the parents are doing themselves.
That's quite that's quite an exciting finding, in the sense that because a lot of the language findings are that the home environment is so important, and the fact that numeracy may have maybe less tied to it is I guess quite an exciting finding and interesting finding that we have.
Yeah, I wouldn't want to give the impression that the home environment isn't important, because it is, and we know that demographic factors are really closely associated with sort of outcomes in maths. I think perhaps it's that when you're doing the research on this, it's very complicated to actually measure accurately what parents are doing. So with reading, for example, most parents can report with reasonable accuracy whether they read to their children at bedtime or not. It's quite a simple thing to ask, and it's quite a simple thing to record. Whereas if we're looking at maths activities, actually some parents might not recognise that the things that they're doing are mathematical or numerical, or they might not even be able to see what the opportunities are to do maths or numerical things with their children. So you're left with trying to measure things that are perhaps poor proxies, and it's quite hard to estimate. If you were asked to how many times have you played board games with your children in the last or on average, how many times a month do you play board games? It's actually quite hard to measure those kinds of things. So I think partly the mixed evidence might be a measurement difficulty, and partly it might be difficulty with parents perhaps identifying where they can do simple numerical activities. And so perhaps if we can help parents identify some of those opportunities, then the home environment could be made to be more of a supportive environment for this early maths and number. In some of the studies we've done, we've really, with parents of children who are sort of 3 to 4, many of them, they know about reading to their children. They've had this message come to them ever since their children were born, but very few people have ever said to them, you know, have you thought about doing number things? Here are some really simple things you can do, things you can do around meal times, things you can do when you're going for walks, and so on. And so they haven't thought about doing it, and they think of maths as being something that happens at school, and that their 3-year-old's too young for this. So I think the mixed evidence is not a sign that children aren't sensitive and what's happening at home doesn't have an influence. It's more a sign that it's hard to research this, and perhaps we need to give parents more input in a really simple way, that doing maths at home with your child is not complicated, it's not scary. You know, even if you had a poor experience with maths at school, that doesn't mean you can't help your child to count the stairs when you're walking upstairs, or really simple things like that.
And just it's put me in mind of putting 2 pizzas out in front of my 4 kids last night, and you know, the youngest ones were watching how many slices each of them had, and to make sure they didn't get left out. I mean, is that home? You know,
yeah, absolutely.
They largely did it themselves, but I guess does that count as a some form of home input to that? I guess.
I think absolutely, and then what we want parents to feel confident to sort of perhaps just ask a question or point something out that is building on what the children are naturally noticing and being interested in, and just perhaps helping that a little bit to helping the child to think about that in a little different way. But noticing these opportunities and supporting children in this way is not easy. Even early years practitioners find that challenging sometimes. So, you know, to expect this of parents who don't have the training is quite a challenge. And so when we do think about talking to parents about home numeracy, I think we have to keep it really simple. We have to keep it really fun, engaging. It's about playing with children. It's about looking at the world around you and just perhaps drawing children's attention to some numerical aspects of the world and all adults can do that. You don't have to have been good at maths yourself to be able to do that.
It's interesting that as you said, like the earliest practitioners are trained in this, and when you do get into that environment, in terms of what the teacher should be doing, I mean, there's a wider debate in the EYFS about how much direct instruction and how much sort of facilitated play or directed play happens, and indeed like not directed play. Do you see maths development as happening organically in unstructured play, also being led in structured play, and through direct instruction? Are they all as equal as each other? Is one better than the other? How what does that environment look like in a sort of successful maths learning environment?
Yeah, so I think it's a really complex question. Everyone's challenge sort of struggling with that at the moment. So within the early years sort of sector, and particularly within the UK, there's very little sort of rigorous big research evidence. So we can't just go to the research evidence and look at where people have compared all these different approaches and said, look, this one's most successful. So if we want to look at what research tells us about this, we need to think about what do we know about children's development, maths development, and what would that suggest is the ways to go. And then what can we take about from some of the more formal intervention studies that have been done, often in the US context or elsewhere. And so, you know, we're trying to draw out what we can infer from these kinds of studies. And I think putting that together suggests that we need balance. So play is so important. Children can learn so much through play, but they're probably not going to get the whole way through in a very unstructured play situation. So what they need is some kind of guidance. They need some kind of structured input, either through the play situations themselves or alongside the play situations, so that we can help them to build on these intuitive and formal skills they have, and actually think about some of the more formal aspects about how we use number, how we represent number. But it's got to be appropriate to the child's age and to their point in development, and it's got to be in a way that's engaging and fun. And you can do a lot of quite structured input, but through play, in the way that the tools that the manipulatives and the representations and things that you're using with children, that, you know, it doesn't have to be, even structured input doesn't have to be children sitting on a carpet and an adult talking to them, or children sitting at a table with worksheets. Structured input can happen outside when you're using stones to represent how many children there are in each group, or whatever it might be. You know, you can do structured input, but in a way that is playful for children. And I think this builds on the best kind of what we know about children's development, but also some of the evidence of some of the big curricular approaches used in the States, like the building blocks approach, where they incorporate some directed teaching, but alongside and in the context of play situations. And with that, a lot of guidance for teachers.
I guess a good example, like when I've been into EYFS settings, is like the kids might have built a house, and the teacher will go and go, oh, how, you know, what's this house? And they, oh, we're going to wash cars. I said, oh, how much are you going to charge me to wash the cars? You know, have you got, what's the pricing system? And the kids are like, oh, I don't know. How much would you charge? And there's a conversation about number that's happening. Do we know why that structured play is a better option, or sometimes is a better option than sitting a child down and saying, well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the number symbols. You know, this very direct, because, you know, intuitively people say, well, that's quicker. Surely it's easier just to tell them rather than this elaborate game approach. Then other people say, well, they're not going to sit there because of self-regulation, because of metacognition. And another is saying, well, if it's part of the game, they're going to learn it easier. I mean, as you said, I know this is a difficult question because the research isn't perhaps there yet, but what's the sort of sense there between the two?
So I think a lot of it comes about with children's kind of experiencing number in lots of different contexts and using lots of different tools to represent number. And also shape is really important here. You know, we're focusing on number in the conversation, but actually all the sort of issues around spatial skills and shape are just as important and can be done in just the same way. So if children are using things where they're manipulating them, they're combining sets, they're comparing sets, and then they're using number words or symbols to represent those sets, then they're really using you know, their whole body. They're really getting involved in the interactions with the tools, and they're thinking about number in a sort of richer context. However, nobody has actually really done a study, to my knowledge, where they have encouraged, you know, directly compared these different approaches. So it really is building on what we know about how children sort of learn or interact in more general contexts, rather than being able to draw on specific studies that have compared that.
And you mentioned shape and space and spatial skills there as part of numeracy. I mean, it's interesting, isn't it? Because it's numeracy, we think of number almost automatically. But, you know, the wider context of maths is angles, is you know, shape, as you say, is how big something is, how small something is, what does it look like? I mean, is that widely recognized enough, that the importance of shape and the importance of space? And I guess the second part of that question is, there's a lot of research coming out around spatial abilities and how that's perhaps slightly the Cinderella of maths, in the sense that schools don't pay enough attention to it, perhaps, or the testing regime doesn't pay enough attention.
Yeah, I mean, so my context is within the research field, and I think within research it's really well recognized how important spatial skills are for maths, and certainly when I go into earlier settings, I see these spatial activities going on all around. So how that feeds into the kind of assessment, I guess I'm not the person to answer that question.
But it is clear, isn't it, that spatial ability is now been linked to not just immediate short-term maths achievement, but long-term achievement in maths.
Yeah, absolutely. And I think so there's we can see sort of obvious areas where the maths curriculum has lots of elements of sort of spatial skills and shape knowledge in it. But also I think there's things going on at a lower level cognitively. The the processes that you're learning and that you're developing, where you're doing kind of spatial activities, or, you know, a building with blocks and all sorts of things like this, these are at a low level of sort of processing numerical information helpful. So it's not just at the obvious kind of surface, the high level skills, but it's also at a lower level of sort of cognitive processing that we think that spatial activities help with number representation and manipulating numbers. You know, the way we represent numbers is so spatially based, whether that's on number lines and things like that, but also multi-digit numbers, of course, have this massive spatial element. And then when we're thinking about operations on number, so we're thinking about addition and subtraction, often we think of those, we conceptualize those or visualize those spatially when we think about, well, which is the set and which is the subset, and do I need to add in this situation or take away in this situation? And actually, so the spatial skills are helping there with actual number processing, and not just the fact that parts of the mathematical curriculum has sort of shape and angles and things on it.
Is it easy to identify someone who is spatially advanced or spatially adept? I mean, can we have a good idea in the sort of structured play environment that you were talking about before? You know, how easy is it to spot that someone may not have the language for maths? They may not, you know, be counting to 15 or 20 or whatever the level that is expected, but actually, can we say, oh, you know, they're manipulating shape very well? I mean, they seem to have a good idea of space. Is that easy?
Yeah, so I don't know, within a sort of practice context, certainly within research, we have ways of like looking at block rotation is mental rotation is a really important skill, and that actually we can see quite differences quite early in children's skill with that. But I do think that you can observe children's engagement with different activities, and often that will tell you something about how comfortable and confident they are in the skills with that. So the children who are always drawn to the Lego pile are likely to be really confident with spatial skills, whereas other children may not. And you mentioned language, of course, which is really important, that you can observe that. Are children using the right kind of spatial language that suggests that underneath that they have these spatial concepts as well?
It's funny because when you're talking about mental block rotation, like, it's one of those things I find really difficult, like to imagine, especially when you see the box net and they say, okay, when you, which of these folded up boxes is the right one, and you can do, there's lots of tests online on that. I mean, is that a good test of spatial ability? I mean, if I'm scoring 3 out of 10 on the rotating block test, does that mean my spatial ability is poor? And I don't mind you saying if it is.
I don't know. Do you know, I don't know enough about spatial assessment, particularly in the early years, so I'm probably not the right person to answer that.
That's absolutely fine. I'm going to take it that I'm still fine on that. In terms of spotting problems, then we've talked about how the children will possibly be on different developmental trajectories. They may have different home settings. Is there a case, you know, at what point do you think a child may need more input? I mean, in terms of where they struggle, how soon should it be flagged in an EYFS setting that actually this child here is struggling a bit more than perhaps we thought they should be? I mean, is that something that you can tell straight away? Is that something you have to try several different interventions to the point where you go, okay, well, nothing seems to be working? How does that work essentially?
So I think there's a couple of things that are important here. So first of all, it's remembering that some of these basic number skills are really complex. So if we look at counting, there is so much involved in learning to count. So it's not just the count sequence, it's knowing how to tag items properly, it's understanding cardinality, what we use counting for, knowing when you can count, knowing what kind of things you can count. So actually trying to work out where a child is and to say that whether a child can count or not is very complex, because you need to actually observe across a whole different kinds of situations to see how children are using their counting skills. And we know that context is so important. So if you wanted to know whether a child could add or not, there's really nice research showing that the context you ask that question has a huge impact on children's success. So if we ask addition problems in a very non-verbal sense using concrete items and no number words at all, then lots of young children are able to do this. But then when we perhaps put it into word form, say, you know, we've got 2 pigs and 2 more pigs, how many pigs are there altogether? You know, some children will also be able to do that, but some of the children who could do the non-verbal concrete addition won't be able to do that. And if you take it another step to ask, well, what's 2 add 2? Then again, some of the children will be able to do that, but others won't. So then you have the challenge of saying, well, what does it, who can add? Who understands addition? Who is able to do this? Because if you require children to be able to do it in all contexts before you say they truly understand it, then that's sort of diminishing the understanding that some children can show when you give them the right supportive context. So I think what I'm trying to say is just assessment is so difficult at these early years. Children are developing in such different rates. They might develop things in different orders from each other, and they might show a skill in one context that they then can't apply in another context until later on. So how you then decide whether a child is on track or not is extremely difficult, because there isn't a simple linear sequence of things that they should do this and then this and this and this. And similarly, there isn't a way of simply deciding, can this child count or can't they? Can this child add or can't they? Because the context has so much impact. So I think in the early years, trying to assess children to determine who needs intervention or not is extremely difficult. And we need to think about really rich observations. And the things that would concern me, rather than a child's sort of score on a particular measure, would be, does the child seem to be making progress? Even if it's slow progress, are they making progress? If you can observe them closely enough, can you see that they're responding to input that they're getting and that they are slowly moving forward? And does there seem to be any particular gaps or things that where you would perhaps expect a child to be able to do something simpler because they can do something more advanced? And then you need to think about, well, what's missing here? Have they learn to do something superficially despite not having the underpinning understanding, and perhaps you need to go back a few steps to have a look and see if you can provide that. And we know that early maths and maths throughout school draws on so many different skills. So there is the understanding about number and mathematical ideas, but there's also, as we talked about, spatial skills, language skills, executive function skills, so self-regulation, things like that. And actually children can be struggling with maths in the early years for a whole range of different reasons. And many of these will resolve as children develop. And so jumping in with interventions too early, I think, can be problematic. And actually intervening unnecessarily and making a child feel like they're struggling can do more harm than good. So it's all about, and the interventions evidence suggests this, it's all about close observation, knowing where a child is at and knowing and being able to help them move a little bit forward. And I think, as I said, if you're giving them the standard kind of close observation and intervention that you would, and that you're not seeing them move forward, perhaps that's the point at which you want to think about something a bit more. But it's just not possible to say that by this point a child should be here with their maths understanding, by this age the child should be here, because it's so varied, and it can be, and even simple skills are actually much more complex in what children have to develop to get there, and they need time to do that.
Yeah, it's interesting, isn't it? From what you're saying there, like we'll make an assumption, you know, on a mark sheet it will say this child can't count to 20, but actually that they might not be able to, from what you said, like the concrete examples, they may be able to do 20 perfectly fine, or so it may be a language problem, or it may be, thinking of what my second son, it may be a self-regulation problem where he gets to 8 and just goes, nah, I'm bored now, and wanders over to play something else. And we're making judgments on children that are perhaps too complex to make at that age.
Well, I think we're actually trying to make simple judgments. The situation is complex, and we're trying to reduce that sometimes to a simple judgment. And that's the difficulty, where actually, you know, it requires a complex assessment to know where children are. And that requires looking at them and the way that they use number in all different situations. So I think the frustrating thing is if you might sit down with a child and ask them to do something and they're unable to do it, and then 2 minutes later they're over in the Lego box and they're showing exactly the skill that you were looking at.
Yeah.
They've just chosen to apply it in different situations, or perhaps with in an environment or a play situation that they're more comfortable in. Then they can use it because they see a purpose for it. Whereas when you were sat down with a piece of paper, it didn't seem relevant to them then.
How does it work? I mean, I'm going slightly off topic because this is focused on early development, but I mean, the shift between EYFS and year one is always talked about as this big shift, and often there's a shift there where concrete, physical aspects of maths begin to fade away as you move up a school. From what you said, that seems that some of those children will be put into a certain context or labeled in a certain way of a lack of understanding because the very tools they used to do maths are suddenly disappearing slightly.
Yeah.
Is that a case where actually they should be able to move on from those concrete objects, or is there anything wrong with using a concrete object as they move through the school?
So I think we should sort of incorporate manipulatives for as long as children want them, and actually they're useful much higher up primary school with new ideas as well. And I think what's important is helping children to see what this manipulative is representing, what it is that you're trying to use it for, and so help that child to make the link between that and perhaps the sort of a more abstract way of representing the same idea that you're hoping to move the child along a bit to. And that sometimes has to be done very gradually. So you can't just take the manipulative away and expect the child to be able to apply what they were doing with the manipulative into a new situation. And this is where sort of a little bit of structured input alongside the play can help. So children start to see, why am I using this tool and what is it representing, and to gradually move to a point where they don't need it anymore. But I'm in favour of manipulatives for, quite far up primary school whenever children need them. And it is true we don't want children to rely on them, and we need to help children understand how they can move beyond them. But sometimes we all count on our fingers sometimes, like no one's taking that opportunity away from us as adults. So we shouldn't really be taking it away from children, but we should help them to, to see how they can think about the same idea or represent the same idea in a different way. And I think the transition from reception to Key Stage 1, it's so important to remember that some of the children are going into Key Stage 1 at only a few weeks older than their classmates were at starting reception.
Yeah.
So to actually have that, if it was right for the eldest in reception at the beginning of reception, then it should be right for the youngest in reception when you move into Key Stage 1. We have a huge age range in children at the beginning of school, and we mustn't overlook that and the impact that has, and allow children to be a bit more fluid as they move from early years maths into Key Stage 1 maths. And I think, and the last thing I just want to say on this is it's really important to make sure that the way we're using representations and the way we're using language is consistent, because one of the most difficult things is children become used to using representations in a certain way and with certain words in reception, and then they move into the next class and suddenly it's a whole new representation and the whole new words, and they won't see the links between what they knew and could do before and this new situation. So lots of conversations to make sure that we're using language in the same way wherever we have transitions, early years transitions, sort of year 6 to year 7 transitions, conversations, so we know that we're using representations and we're using language consistently, and we can help children see that the maths is the same even if it's moving up a little bit.
And do they, are children adept at sort of a performative kind of maths where they can say, they've basically learnt 2 + 2 is 4. They don't really know what that means, but and the same with times tables, 6, 12, 18, 24. They can reel it off to you. But how do you know if that's just learned words rather than a mathematical understanding? And lots of people talk about automaticity. I'll try and say it again, automaticity. And does it matter if they don't understand fully that 6 times 6 is 36? Is it? Yes. Is it if it's in the context of another procedural sum? I mean, there's a few questions there, I know, but I'm trying to get into the sense of some children might just be very good at remembering numbers and sums, and they may not have fully grasped what that is.
Yeah, so I think this is a really complex area, obviously. Ideally, what we want, well, not just ideally, what we want is children to understand the maths that they're doing, and to come to know these number facts through understanding. So I think one of the things that is really important to remember is that being able to automatically retrieve an answer doesn't mean you ever had to rote learn that answer. Yeah. So you can come to know your number facts, you can come to know your times tables through experiencing, repeated opportunities to do those sums. So, within the context of addition, for example, if children spend lots of time using manipulatives to combine sets of 2 and 2, and then perhaps do it on a number line and perhaps do it in a 5 frame or a 10 frame, over time, over these experiences, they will come to know what the answer, they will come to know that 2 add 2 is 4 without ever having to rote learn that. So that means that you haven't got this separation between the number fact and the understanding, because they've come to learn the fact through these rich experiences. And I think one of the concerns I have about the automaticity of number facts in early years is that this makes people think that we have to go through a rote learning and that we have to go via the abstract written straight away, and that's the only way of children getting to automaticity. I think with the right kind of rich experiences, lots of early years children may be able to get to a point where they can retrieve some of these number facts. And for some children, that will be totally appropriate. But if we make it too much of a target for all children, then it might lead to the rote learned approach. And that will be too soon. And for some children, it will be this separation between, I can say 2 add 2 is 4, but I have no sense of what that means. Yeah. And that, that's just not helpful at all going forwards. So you can get to retrieval through rich experiences, and with timetables, you can do it through like different mental strategies to work out the answers. It doesn't have to be rote learning. Some children like rote learning, and for times tables, for some children that's a strategy they're happy with. But for lots of children, doing it through a variety of experiences with the number fact is much better, because they end up being able to retrieve it, but also being able to understand it.
And I guess that brings me to sort of my last question, which is that with literacy, we have these very clear building blocks, it's heavily researched, heavily invested in, and there's a pathway that seems relatively simple to follow. We go through step 1, step 2, step 3, and we have a reader. There's interpretations of how effective that route is, but there is a clear route for people to pass. There doesn't seem to be a clear route for maths. There doesn't seem to be as much investment for maths in terms of research, and as much attention, I guess, on it. I guess my question there is, why is that? And do you think that there will ever be a way of creating as clear a structure for maths as there is for reading?
So I think that it is changing within research. So when I first got into maths research, my interest was drawn because nobody, there was so much less of it, and research on reading or language. And within research, there's just been this explosion in the last 20 years. There's so much more now than there was in the 90s, early 2000s. But it is true that it doesn't seem to, it's still not of the scale of the investment in research on reading and language. I don't think we will ever have such a simple kind of approach and be able to say that these are the things that you need to do and these are the order and that you can get to maths. And the reason for that is I think there's just so many skills and there's so many aspects of maths. So not wanting to diminish reading, because obviously there's much more to reading than decoding. But I think with maths, it's even broader than that. And, we need to think about numbers. There's so many different aspects of numbers, the cardinal aspects, there's ordinal aspects, there's shape, there's space, there's so much going on there that there is never going to be, we're not going to find our phonics equivalent where there's one simple approach and we can say, follow this sequence, and then for most children, they'll get there. It's always going to be much more complex. And I think children develop in different orders. This is the real challenge with maths, not just that children go at different rates, but some children might develop confidence with certain aspects of maths before others. And so that makes it very difficult to have any kind of linear trajectory where you kind of say this is where a child is for maths. Now, you could do those kind of trajectories for smaller, more focused topics within maths, but you're not going to be able to have one overarching, sort of the equivalent of a reading scheme for maths.
I think that's quite a freeing concept for teachers, because it does put the control back to teachers, and it does allow teachers to react to the child in front of them, which from what you said across this podcast is really important, to react to the child.
Definitely. And that's the one thing that I, when I go and talk to teachers and inset days and things, if someone's selling you a silver bullet for maths, then don't buy it, because it's just not going to exist. It's complex. It requires so much expertise and knowledge in the part of the teacher, and understanding of the child and where they are at, and thinking about what they know, what they bring to a mathematical situation, and how you can just perhaps draw out more, point them in a new direction to go a little bit further along.
Camilla, thank you very much.
Thanks very much. It's been a pleasure.